Hello everyone. So this is our fourth class on matrices. Devashish again from Dev's Learning Hub. The three classes I have covered on matrices, where I have covered more or less all the major items, properties of matrix, what is order of matrix, how the addition, subtraction, multiplication of matrices, and also the properties, respective properties. So this is the last class where I am going to cover additive identity and additive inverse quickly, and then I will do few of the important examples on matrices chapter. The topics what already I have covered in my last three classes and also in this class. So you will get the overall understanding and application of the knowledge what you have gathered so far, right? So let's start. So additive identity and additive inverse, these two are very common term. I hope all of you know that with respect to number or the rational number rather, right? So additive identity, you know that 0 is the additive identity for any number. Why it is called additive identity? Because if you add that number to any given number, there is no change. So 0 is called the additive identity for rational numbers, because if you add 0 to any number, it doesn't impact the output. 5 plus 0, 5. Minus 7 plus 0, minus 7. So this is what additive identity with respect to numbers or rational number. 0 means in matrix it is actually the null matrix. So if you add a null matrix to a given matrix, then the matrix, the matrix output doesn't get any change. So it is just equal to, so let's say there is one matrix 1, 2, 3, 4, and there is one null matrix that is 0, 0, 0, 0. As you know, based on the properties that you can add or subtract two matrices when they are of the same order. So here the order it is for matrix A, the order is 2 by 2, 2 rows and 2 columns, and this is also 2 by 2, 2 rows and 2 columns. So now if you add these two, so what will be the output matrix? A plus O, that is equals to, in addition or subtraction, just you will add or subtract the corresponding element in both the matrices. So first row, first column element is 1. First row, first column element of null matrix, it is 0. So it is 1 plus 0, 2 plus 0, 3 plus 0, and 4 plus 0. So altogether, what will be the matrix? Again, it is 1, 2, 3, and 4. Right, which is equals to matrix A. That means matrix A plus matrix null matrix equals to matrix A. So that is why null matrix is the additive identity in the matrix system, whereas 0 is the additive matrix. 0 is the additive identity for rational number, right? Additive inverse. What is the additive inverse with respect to number system or rational number? If there is a number called 5, then what is the additive inverse of 5? That is minus 5. If there is one number minus 5, what is the additive inverse to that number? It is plus 5. Why? Because additive inverse means you will multiply the given number with minus 1. That means minus 5 equals to 5 into minus 1. And the property is that any number plus its additive inverse, that is equals to 0. Because it is just the opposite sign but the same numerical value, right? So additive number is 5, additive inverse is minus 5. So therefore 5 plus minus 5, that is equals to 0. The same thing here for in matrix also. Additive inverse means for a given matrix, if you are asked to find out the additive inverse, that means you need to multiply that given matrix with minus 1, the scalar value. That means you need to multiply all the elements of that particular matrix with -1. Let's say there is one matrix, 2 by 3 matrix, right, A, right? So what will be the additive inverse of matrix A? That means you need to multiply this with -1. So it will be -1 into matrix A. That means what will be the elements, values? -2, -3, -4, -1, 0, -5. Right? Let's say this additive inverse is termed as B. So if you sum up A plus B, that means the matrix with its additive inverse, then it will return a null matrix. For number system, it returns 0. Here it will return 0 means it is in matrix system, it is null matrix. It means you will add the corresponding elements. 2 plus -2, that means 0. 3 plus -3, 0. 4 plus -4, 0. 1 plus -1, 0. 0 plus 0, 0. 5 plus -5, 0. So basically it's a null matrix. So additive inverse of a matrix is the null matrix. Additive inverse of a rational number is 0. Additive identity of a rational number, that is 0, because if you add 0 to a number, there is no change in the number. And in matrix system, additive identity, that is the null matrix, right? So in matrix system, additive identity means actually null matrix. So relation is given a matrix plus additive identity or null matrix, it returns the same matrix again. It is A. Now for additive inverse, that is nothing but the negative of the given matrix. So A is the matrix plus its additive inverse means A plus minus matrix of A is multiplied by -1. That means the resultant matrix is the null matrix. So basically this is what the relationship. Okay, let's do few true false statements. Just analyze, just conceptual thing, nothing else, right? First one is square bracket A, that means matrix A. Matrix A is of order 3 by 2. And same for, that means order for matrix B is 2 by 3. So addition of A and B matrix is possible. Yeah, true or false? It is possible. It's saying matrix A plus matrix B. Addition of these two matrices is possible. Is it possible? No, it is not possible. You can do addition or subtraction of two matrices only when both the matrices are of the same order. Whereas here order of A is 3 by 2, order of B is 2 by 3. So you cannot do that. It is false. If for false. Next is matrix A 2 by 3, which is a 2 by 3 matrix, and matrix B, which is also a 2 by 3 matrix, are conformable for subtraction. That means yes, it is conformable for subtraction because both the matrices have the same order. So it's a true statement. Third one is transpose of a 2 by 1 matrix is also a 2 by 1 matrix. Is it true or false? Refer to my, for number 1, number 2, refer to my second class. For this one, transpose of a 2 by 1 matrix is also a 2 by 1 matrix. For that is also you can refer to my earlier video, second and third, right? So what is transpose of matrix? You know that when you are transposing a matrix, that means actually you are converting the rows into columns. That means you are converting the columns into rows. So that means if you have a matrix like this, 2, 3, 5, 4, 2, 3, 6, 4, 5, 7, this is a given matrix. So it is a 2 rows, 3 columns, 2 by 3 matrix. Now when you will convert it, when you will transpose it, that means 2, 3, 6, this will be, the first row will be first column, 2, 3, 6, and second row will be second column, 4, 5, 7. So this is, if this is matrix A, then transpose of matrix A is 2, 3, 6, 4, 5, 7. That means it will be, now it is 3 by 2 matrix. So when you will transpose a matrix, so its number of the order will be reversed. If it is the order is m by n, then transpose matrix will have the order n by m, not m by n, right? So if it is saying that transpose of a 2 by 1 matrix is also a 2 by 1 matrix. It's a false statement because transpose of a 2 by 1 matrix will be 1 by 2 matrix. So it is a false statement. Next, transpose of a square matrix is a square matrix. That is obviously because in the square matrix you have same number of rows and columns. So it doesn't matter whether the rows will change to be column and columns will be changed to rows. The elements will be changed, but the order will not be changed, because if the order is 2 by 2, 3 by 3, whatever it is, so number of rows will be number of column in the transpose matrix, and number of columns in the original matrix will be number of rows in the transpose matrix. So effectively there is no change. So transpose of a square matrix is also a square matrix. It is absolutely true. But transpose of a rectangular matrix will have the same order. That is absolutely wrong statement. Right? A column matrix has many columns and only one row. I explained in the type of matrix in my first class. What is row matrix? Row matrix means if in a matrix you have just one row, it doesn't matter how many columns it is there. It may have 2 columns, 3 columns, 4 columns, whatever it is so, but one row, that is called row matrix. And for column matrix, if the matrix has just one column, it doesn't matter how many rows are there. It could be 1 column, 2 rows, 1 column, 3 rows, 1 column, n number of rows, but column is 1. So a column matrix has many columns and only one row. That is absolutely a wrong statement. Column matrix has only one column but many rows. So it is a false statement. So if matrix A is of order 3 by 2 and same for B is 2 by 3, right? Order is one is 3 by 2, one is 2 by 3. Can you add these two matrices? Is possible? It is the statement. It is possible. No, it is not possible, because if you can do addition or subtraction of two matrices only when the order is same for both the matrices. So it's a false statement. A matrix 2 by 3 matrix A and 2 by 3 matrix B are conformable for subtraction. Yes, it is very much true, because both the cases the order is same. That means you can do subtraction, right? Subtraction. Transpose of a 2 by 1 matrix is also a 2 by 1 matrix. It is false, because when you are transposing a matrix, its number of rows are you are converting the rows into columns and columns into rows. So basically the order will be reversed. So if in a transpose, if in a given matrix the order is m by n, in a transpose matrix the order will be changed from m by n to n by n, right? So transpose of a 2 by 1 matrix is also a 2 by 1 matrix. That is absolutely a false statement, right? It should be 1 by 2 matrix, the transpose matrix, right? Transpose of a square matrix is also a square matrix. It is absolutely true, because in square matrix you have same number of rows and columns. So therefore, even though rows will be changed to column, column will be changed to rows, the elements within the matrix will be changed, but the order will not be changed. A column matrix has many columns and only one row. It is a false statement, because a column matrix has only one column. It may have multiple rows. And in row matrix, it will have only one row but may have multiple columns. So this is a false statement. Okay, this is a very interesting example. If for two matrices M and N, matrix N is given, and the M into N, that is the product of matrix M and N, that is also given, -1, 4. Then find matrix N. A very interesting and very important example. It is high probability of having this kind of example in your exam, right? So just break this problem statement. If you need to find a matrix, what are the things you need to know? You need to know the order of the matrix, and you need to know the elements of the matrix. These are the things you need to know, right? If I say matrix A of order, you can multiply two matrices only when the number of column in the first matrix is equal to the number of rows in the second matrix. It is very clearly explained in the third class, right? So A of m by n into B of n by p, then the resultant matrix will have the same number of rows of first matrix and the same number of columns of the second matrix. So will be AB will have the order m by p. That is what already we have learned in our last class. So here what it is given, the output matrix it is already given, right? That is minus 1 4. Minus 1 4. So matrix n, it is given. What is the order of the matrix n? It is 2 rows and 2 columns. So it is 2 by 2. The output matrix that is given, which is order of 1 row 2 columns. Now what will be the, from these two values, how you will assume, it is not assume, already it is told what will be the order of matrix n. Now if I represent like this, matrix m, I don't know what is the order. Matrix n given one, it is 2 by 2 matrix, and the resultant matrix, that is 1 by 2. So if you look into this, then you can do multiplication of two matrices only when the number of column in the first matrix is equal to the number of row in the second matrix. So second matrix row is given 2. That means definitely the number of columns in the first matrix, that is also 2. Now what will be the number of rows? You know, if the multiplication is possible of between two matrices, then the resultant matrix will have the equal number of rows of matrix A, first matrix, and equal number of column of the second matrix. Here we can see the resultant matrix is 1 by 2. That means its number of rows will be equal to the number of rows of matrix, first matrix. That means matrix M also will have 1 row. So now you achieved this one. Order you know. Order of matrix A you have found out, right? Now you need to find out the elements, right? If order of matrix A it is 1 row 2 columns, now you assume the values, one value is x and another value is y, because it has 1 row 2 columns. That means you need to put the values x, y like this, not x, y vertically, because in that case it will have 2 rows 1 column, but we have already found out the order is 1 by 2. That means you will put the elements in this manner, x, y, and then the value of n, it is 3, 2, 2, minus 1. That is equals to minus 1, 4. Now you find out two equations from here, just product of matrix. Row versus column, 3x plus 2y. So 3x plus 2y. Another element is with first row with second column, 2x minus y. 2x minus y equals to minus 1, 4. Now these two matrices are equal. If the two matrices are equal, that means their respective element also will be equal. That means what you can say from here, 3x plus 2y equals to minus 1. First element versus first element, minus 1. And another one will be 2x minus y equals to 4. So if you solve these two equations, this is equation 1, this is equation 2. Now if you solve these two equations, what will be the value of x and y? So 3x plus 2y, if you multiply this equation also with 2 and then you add, that means, so 3x plus 4x, 7x equals to 7. That means 7x equals to 7, that is x equals to 1. So you found out one element x. 3x plus 2y equals to minus 1. The first equation, you replace the value of x, that is 3 plus 2y equals to minus 1. That means, or y equals to minus 2. Y equals to minus 2. 2y equals to minus 4, y equals to minus 2. So these two are two values of the elements of matrix M. So what will be the matrix M? Matrix M is x, y, that is 1 minus 2. This is very important kind of problem. Not exactly same, but that is how you need to resolve. There are multiple problems like this. So our third problem, if a given matrix A is 5 minus 2 7 0 and another matrix B is given, then which of the following is not possible? There are four scenarios has been given: A square, AB, third option is B, and fourth option is 15A. Out of these four options, which is not possible given the matrix A and B? So that means actually what you can see, understand the problem first, that you need to see all these are product of matrix. So you need to utilize the properties of matrix multiplication, right? So what is the property? Property, first of all, you can do the matrix multiplication only when the number of columns in the first matrix is equal to the number of rows in the second matrix, right? What is the order of this matrix? The order of this matrix is 2 rows and 2 columns, that is 2 by 2 matrix. What is the order of this matrix? Order of this matrix is 2 rows 1 column, that means 2 by 1. So now come 1 by 1. So A square, that means A into A. If A square, that is equals to A into A. That means when you are multiplying A with A, so number of both, since it's a square matrix, both rows and columns are equal. That means A square is possible. The number of columns in the first matrix, that is 1A, and that is equal to the number of rows in the second matrix, that is also A. So both the cases, and both the cases, the number of column and the number of rows are same. That means A square, it is possible. This one is possible. AB, is it possible? Number of columns in A is 2, equal to the number of rows in B. That means AB is also possible. BA, number of column in B is 1, number of row in A is 2. That means BA is not possible. 15A, you are just multiplying a matrix with scalar values. Always it is possible, right? That means it is also possible. So which is not possible? BA is not possible here. So I hope you like this class, and this is a very important kind of problems I have given you the example here, which is very much useful to solve different kind of, because I have used addition properties, subtraction properties, what is transpose matrix, row matrix, column matrix, and multiplication properties. Lot of things already have been covered with these 3 or 4 problem sums, right? And you have understood, I believe, additive identity and additive inverse also with the example. So if you like this video, please click on the like button. And if you would like to have this kind of conceptual video again and again, please subscribe my channel, Dev's Learning Hub. Okay, thank you very much.